Hello everyone. Welcome to Wallah channel. Okay. So today we are going to see pattern matching. Today we are going to see pattern matching or string matching. Okay. So this is the QR code of my compiler design textbook. This will be helpful for BTech, MTech as well as for GATE. If you have not bought it, please buy it from PW store. Okay. And this is the QR code of my Telegram channel. Please join the Telegram channel. Right. Okay. In the previous class, we were seeing context-free languages. Now also we will see context-free languages. Now also we will see context-free languages. Okay. So how do you write even length palindromes? So how do you write even length palindromes? How do you write even length palindromes? You can answer in the Telegram channel. You can answer in the Telegram channel. You can answer in Telegram channel. How do you write even length palindromes? Hi Ujjwal, good evening. It's not even evening. It's not even evening. It's almost midnight. You can say good morning. Okay. Fine. How do you write even length palindromes? How do you write even length palindromes? Answer it in the Telegram channel. So you can write even length palindromes like this: w power r such that w belong to a comma b star. W power r such that w belong to a comma b star. This is how you write even length palindromes. This is how you write even length palindromes. Right? How do you write odd length palindromes? You can answer in Telegram channel. Okay? How do you write odd length palindromes. How do you write odd length palindromes? So you can write odd length palindromes like this: Wx, W power r, W belong to A comma B star, and X belong to A comma B. X belong to A comma B. Very good, Roshan. Very good. Now tell me, how do you write all palindromes? All of you, please join this Telegram channel. You can write your answers in the Telegram channel. All of you, please scan this and join the Telegram channel. You can write your answers in the Telegram channel. You can write the answers in the Telegram channel. All of you, please join this Telegram channel. Right? Okay. So how do you write all palindromes? Even length WWR, odd length WXWR, such that W belong to A comma B star, X belong to A comma B. How do you write all palindromes? Very good, Roshan. So all palindromes you can write like this: Wx, W power r, such that W belong to A comma B star and X belong to A comma B comma epsilon. A comma B comma epsilon. Right? Right? Now, how do you write hash palindromes? What is a hash palindrome? It is a even length, it is a odd length palindrome with hash symbol in the in between. Hash palindrome. It is a odd length palindrome with hash in between. With hash in the middle. It is a odd length palindrome with hash in the middle. It is a odd length palindrome with hash in the middle. It is a odd length palindrome with hash in the middle. How do you write it? It is a odd length palindrome with hash in the middle. How do you write it? How do you write hash palindrome? Very good, Roshan. Hash palindrome, you can write it as W hash W power r, such that W belong to A comma B star and hash not equal to A or B, and hash not equal to A or B. Hash does not belong to A or B, right? Right. Now give the context-free grammar for even palindrome. Now give the context-free grammar for even palindrome. Give the context-free grammar for even palindrome. Give the context-free grammar for even palindrome. Give the context-free grammar for even length palindrome. Give the context-free grammar for even length palindrome. Give the context-free language for even length palindrome. Very good, Adesh. Roshan, what is your answer? Roshan, what is your answer for even length palindrome? What is your answer? Please answer in the Telegram channel. You can write the answer on a paper, take a picture of it, post it on Telegram channel, right? Hi, Nucleus. Thank you so much. Thank you so much for your kind words, Nucleus. Thank you so much for your kind words. Very good, Roshan. So for even length palindromes, it is S derives ASA or BSB or epsilon. ASA or BSB or epsilon. S derives ASA or BSB or epsilon. Now tell me odd length palindromes. Odd length palindromes. What is the context-free grammar for odd length palindromes? What is your name, Nucleus? What is your actual name, nucleus? Give me the context-free grammar for odd length palindromes. Give me the context-free grammar for odd length palindromes. Very good. So S derives ASA or BSB or A or B. Give me the context-free grammar for all palindromes. Give me the context-free grammar for all palindromes. Give me the context-free grammar for all palindromes, both even and odd. Both even and odd. All palindromes, both even and odd. Context-free grammar for all palindromes, both even and odd. Give the context-free grammar for all palindromes. Give the context-free grammar for all palindromes, even and odd. You have given for even, you have given for odd. Now I am asking all, even plus odd. all palindromes, even plus odd. Very good, Adesh. Very good, Roshan. So S derives ASA or BSB or A or B or epsilon. Right? Now give the context free grammar for hash palindromes. Now give the context free language for context free grammar for hash palindromes. Give the context free grammar for hash palindromes. Hash palindromes where hash appears in the middle. Where hash appears in the middle. What is hash palindrome? W hash W power R, where W belong to A comma B star, right? Now give the context free grammar for hash palindromes. Now give the context free grammar for hash palindromes. Very good. S derives ASA or BSB or hash. If we generate a in the beginning, generate a in the ending. B in the beginning, B in the ending, right? If you want to stop it with hash, so that hash will come in the middle. Hash will come in the middle. Okay. Okay. So now there is a interesting topic in context free grammars. So we know that we have regular languages, deterministic context free languages, and context free languages. Regular DCFL and CFL, right? Now when a language is here, if a language is here, this is deterministic context free language but not regular. If a language is here, this is non-deterministic context free language, not deterministic context free language, right? Now the question is, they may ask you a question about whether the language falls here or the language falls here, right? For this, you should understand the limitations of deterministic pushdown automata. Then you'll understand why a language is deterministic context-free language and why a language is context-free language, right? Right. Now, let us see limitations of deterministic pushdown automata. Limitations of deterministic pushdown automata, right? So first point is, if when to push, if when to push or when to pop is not clear, then DPDA fails. Then DPDA fails, right? So give me an example of this language where we don't know when to push or when to pop. Where we don't know when to push or when to pop. Give me an example of a language where we don't know when to push or when to pop, right? Where we don't know when to push or when to pop. Give me an example of context-free language where we don't know when to push or when to pop. Very good. So palindrome is an example, right? Palindrome is an example where we don't know when to push and when to pop. Now what palindromes? Roshan, you said palindrome. What palindromes fall under non-deterministic context-free languages? Non-deterministic context-free languages. What palindromes fall under non-deterministic context-free languages? So you can say even palindromes, okay? Even palindromes. We don't know when to push, when to pop. And odd palindromes. We don't know when to push, when to pop. And all palindromes. All palindromes. Very good, Roshan. Except hash palindromes, right? So all these fall under non-deterministic context-free languages because deterministic pushdown automata does not know when to push and when to pop. Only palindrome is hash palindrome. In hash palindrome, we know exactly the center So till the center we will push, and after the center we will pop, right? So in this case, hash palindrome is a deterministic context-free language because DPDA can accept it. DPDA will work for hash palindrome because we know the center. Till center we will push, after center we will pop. Till center we will push, after center we will pop, right? So we can say that these languages are context-free languages, but not deterministic context-free languages. But not deterministic context-free languages. But not deterministic context-free languages. Okay. And the second limitation is, how much to push is not clear. How much to push is not clear, then it is not deterministic context-free language. Then it is not deterministic context-free language. How much to push is not clear. What is the example for this? What is the example for how much to pop is not clear? What is the example for how much to push is not clear? Can you give me an example for this? Can you give me an example for this? Can you give me an example for this? How much to push is not clear, then it is not DCFL. Then it is not DCFL. Roshan, Adesh. So I'll give you an example. Okay. So the example is A power n, B power n, union A power n, B power 2n, such that n is greater than or equal to 0. A power n, B power n union A power n, B power 2n, such that n is greater than or equal to 0. A power n, B power n union A power n, B power 2n, such that n is greater than or equal to 0. Right? So in this, on seeing a, should I push 2 A's or 1 A is a question. So this language is not DCFL. This language is CFL, not DCFL. Right? Right? Similarly, if you have a language like this, W such that number of A's in W is equal to number of B's in W, or number of A's in W is equal to 2 times number of B's in W is equal to 2 times number of B's in W. Now in this case also we don't know how many A's to push. Either you should push 1A or 2A, right? So this is also context free language, not DCFL. This is also context free language, not DCFL. Context free language, not DCFL. Not DCFL, right? Right. Now third one is double comparison with OR. Double comparison with OR. Double comparison with OR. Can you give me an example for this? Double comparison with OR. Double comparison with OR. Can you give me an example for this? Double comparison with OR. Can you give an example for this? Can you give an example for this double comparison with OR? So one example will be a power m, b power n, c power p, a power m, b power n, c power p, such that m is equal to n or m is equal to p, right? So here we are checking either m equal to n or m equal to p. Double comparison with OR. In this case, you have to go with non-deterministic pushdown automata. One path will check for m equal to n, other path will check for m equal to p, right? So this language is not deterministic context-free language, but this language is context-free language because it is non-deterministic context-free language, right? Now tell me about this. If I have a power m, b power n, c power p such that m equal to n and m equal to p. What is this language? M equal to n and m equal to p. There are double comparison, but there is a and. Double comparison with a and. Very good. So this language is not CFL. This language is not CFL, right? This language is not CFL. This language is CSL, right? Tell me about this. A power m, b power n such that n is less than or equal to m is less than or equal to 2n. Double comparison, right? double comparison. So this language is CFL but not DCFL. This language is CFL but not DCFL. Tell me about this. W such that number of A's in W equal to number of B's, or number of A's in W is equal to number of C's. Number of A's in W equal to number of B's, or number of A's in W equal to number of C's. Number of A's equal to B's, or number of A's equal to C's. Number of A's equal to B's, or number of A's equal to C's. What language is this? So this language is also non-deterministic context-free language, because you are going to give NPDA, and in NPDA one path will check for A's equal to B's and other path will check for A's equal to C's. So this language is context-free language but not DCFL. Right? Okay. Now I'll give you some languages. Tell me whether they are regular or DCFL or CFL. Okay. Tell me whether they are regular or DCFL or CFL. W power R union 0, 1 star such that W belong to 0, 1 star, such that W belong to 0, 1 star. W power R union 0, 1 star such that W belong to 0, 1 star. Such that W belong to 0, 1 star. What is the answer? Roshan, Adesh? What is the answer for this? Very good. Regular, right? So any language, when you union with universal language, you are going to get universal language, right? So here you are going to get 0 plus 1 star. This is a regular language, right? Now what is the finite automata? It is 0, 1. This is the finite automata, right? Now tell me about this. W power R such that W belong to 0, 1 star. What language is this? What language is this? W power R such that W belong to 0, 1 star. Such that W belong to 0, 1 star. Very good. This is CFL, not DCFL. Even length palindromes, not DCFL, right? Now answer this question. W power R such that W belong to A star. W power R W power R such that W belong to A star. What is this language? What is this language? Very good. This is regular, right? This language is regular. Now, what are these strings you will get? You will get epsilon. If I put W equal to A, I get A. If I put W equal to A, I get A, so on, right? So the language is A star. So the language is A star, right? Now answer this question. WR power star such that W belong to A star. W belong to A star. W power. Hi Mohit. It is almost good morning. In 10 minutes you have to say good morning. Very good. This is regular, right? So this can become epsilon. Then I will get W, right? W concatenated with epsilon. Then I get W. And W is A star. So I get A star. and A star is regular. A star is regular. Now answer this question. W hash W power R such that W belong to A star. W hash W power R such that W belong to A star. Very good, Roshan. So this is DCFL, right? Why? If W equal to A, then we are going to write A hash A, right? A hash A. Now, a finite automata, if you have to design for this, you have to add, you have to count all the 4A's and you have to see that 4A's are after hash. But finite automata cannot do counting. So this can be done by pushdown automata and it can be done by deterministic pushdown automata. Why? Because we know that till hash we have to push and after hash we have to pop. Till hash we have to push and after hash we have to pop. After hash we have to pop. After hash we have to pop. Therefore this is DCFL and so you can say it is CFL also. Okay. Now answer this. W power R such that W belong to A comma B star and mod W less than or equal to 10. Mod W less than or equal to 10. Mod W less than or equal to 10. WWR such that W belong to A comma B star and mod W less than or equal to 10. Very good. So this language is finite. This language is finite and therefore it is regular. This language is finite, therefore it is regular. Therefore it is regular, right? Now answer this question. W such that W belong to A comma B. W such that W belong to A comma B. w such that w belong to a comma b. What is the language? So w, w and w, and w can be a or b, w can be a or b, w can be a or b. So this is nothing but strings of length 3, right? This is a finite language. This is a finite language, and so it is regular. This is a finite language, and so it is regular, right? So if you draw the finite automata, it is going to be 3 length string, a comma b 1 length, a comma b 2 length, a comma b 3 length. 3 length string. After 3 length, if you get a comma b, you are going to kill it. After 3 length, if you get a comma b, you are going to kill it. You are going to kill it. Okay. Okay. Fine. We are going to end this session here. We'll continue tomorrow. Good morning, everyone. Okay. Thank you and Jai Hind.